Welcome to Still Science Lab. Tonight, we are going to challenge the most absolute law in the known universe. We are going to stand before the ultimate barrier, the iron wall that separates the past from the future, and we are going to ask if it is possible to break through. Our subject tonight is tachyons, breaking the cosmic speed limit. This is a journey into the forbidden territory of physics, a place where the rules of reality, as we know them, begin to warp, twist, and perhaps even shatter. Before we can understand the thing that breaks the rule, however, we must first understand the rule itself. We must understand the cage before we can look for the key. Reach out your hand and flip a light switch. In the exact moment your finger clicks the plastic, the room floods with illumination. It feels instantaneous. To your eyes, there is no gap, no delay, no hesitation. The bulb glows, and the wall opposite the bulb shines at the exact same time. This immediate connection is the bedrock of our human experience. We perceive the world as happening now. We see things as they are, in real time. But this is a deception. It is a biological illusion created by the limitations of our senses. If you could slow down time, if you could stretch a single second into 1,000 years, you would see something very different. You would see that when the filament in the bulb ignites, it releases a packet of energy. That packet, that photon, has to travel. It has to swim through the air, inch by inch, meter by meter, until it smashes into the paint on your wall and bounces into your eye. It takes time. It is incomprehensibly fast, but it is not instant. For most of human history, we didn't know this. We believed that light was infinite. We believed that if a star exploded on the edge of the universe, we would see it at the exact moment it happened. We thought light was simply a condition of space, like transparency, but we were wrong. We discovered that light is a traveler. It has a speed, and not just any speed, it has a specific, finite, and unbreakable speed. We call it c, 300,000 kilometers per second. It is a number so large it becomes abstract to the human mind. But in the grand scale of the cosmos, it is agonizingly slow. It takes light over a second to reach us from the moon. It takes 8 minutes to travel from the Sunday. It takes years to reach the nearest star, and billions of years to reach the edge of the observable universe. When you look at the stars, you are not looking at the present. You are looking at a slideshow of the ancient past. But why does this specific speed exist? Why is it 300,000 kilometers per second? Why not a million? Why not infinite? This brings us to the core concept of our reality. The speed of light is not actually about light. Light just happens to be the most famous thing that travels at this speed because it has no mass. The speed limit is a property of space-time itself. You should think of c not as the speed of a photon, but as the speed of causality. It is the speed of information. It is the maximum frame rate of the universe. Imagine reality is a massive, complex computer simulation. In a video game, the computer needs time to process an event and render the result. If you shoot a digital gun in a game, the bullet doesn't hit the wall instantly. The code has to calculate the trajectory. The universe works the same way. There is a fundamental latency to existence. If the sun were to suddenly vanish right now, disappeared by a cosmic magician, we would not know. We would not feel a change in gravity. We would not see the sky go dark. We would continue to orbit a ghost for 8 minutes and 20 seconds. We would bask in the warmth of a star that no longer exists. This is because the news of the sun's death cannot travel faster than c. The gravitational ripples and the photons are both stuck in traffic, obeying the speed limit. This limit acts as the glue that holds the narrative of the universe together. It ensures that cause always comes before effect. If information could travel instantly or infinitely fast, the fabric of logic would unravel. You could have effects appearing before their causes. You could have answers arriving before questions. The speed limit is the universe's way of keeping the story straight, ensuring that time flows in one clear, consistent direction. It creates a local reality for every object. We are all trapped in our own bubbles of time, connected to each other only by the delayed messages we send back and forth across the void. For over a century, since the time of Albert Einstein, this limit has been treated as a law written in stone. It is the commandment of special relativity. Thou shalt not go faster than light. The theory explains that as you accelerate an object with mass like a spaceship, or a baseball, or a proton, you have to pump energy into it. As you get closer to the speed of light, something strange happens. The object doesn't just get faster, it gets heavier in a relativistic sense. Its momentum increases exponentially. To push a single electron to 100% of the speed of light would require an infinite amount of energy. It would require more energy than exists in the entire observable universe. This is the wall. This is the barrier. As you approach C, the universe demands a tax you cannot pay. The door slams shut. This is why we are stuck. We look at the vast distances between the galaxies, and we feel a sense of despair. Even if we built the perfect engine, even if we rode a beam of light, it would take us 100,000 years just to cross our own galaxy. We are imprisoned by C. The speed limit dictates that we are effectively quarantined in our tiny corner of space, forever separated from the rest of the cosmos by the insurmountable gulf of time. The speed of light defines the boundaries of our cage. However, science is the art of asking dangerous questions. And there is a question that has haunted physicists for decades. A whisper in the back of the lecture hall. A ghost in the equations. The question is, what if we are looking at the problem upside down? Einstein's equations tell us that we cannot accelerate to the speed of light. They tell us that we cannot start from zero and push our way through the barrier. The wall is impenetrable from this side, but the math does not explicitly forbid something from existing on the other side. The equations of relativity are symmetric. They suggest a mirror world. They suggest that the barrier of light speed might not be a ceiling, but a floor. Imagine a particle that was never born at rest. Imagine a particle that did not have to accelerate. Imagine a particle that was created in the very moment of its birth, already moving faster than light. A particle for whom the speed of light is the slowest speed it can possibly go. A particle that requires infinite energy to slow down to the speed of light, just as we require infinite energy to speed up to it. This is not science fiction. This is a legitimate solution to the mathematical framework of relativity. We call this hypothetical particle the tachyon. If it exists, it breaks everything we understand about the structure of reality. If it exists, it is immune to the latency of the universe. It moves faster than the refresh rate. It moves faster than causality. It is a runner that arrives at the finish line before the starting gun is fired. The existence of such a thing seems impossible. It feels like a violation of the natural order. But the history of physics is the history of finding things that should not be. We didn't think antimatter was real until we found it in the math, and then found it in the lab. We didn't think black holes were real until we saw stars orbiting nothingness. The math allows for tachyons. The universe has not yet told us no, it has only remained silent. So, as we stare at the speed of light, that absolute, unyielding number, we have to wonder, is it truly the limit? Or is it just the surface of a deeper, stranger ocean? Is the wall a barrier, or is it a mirror? Tonight, we are going to step through the glass. We are going to explore the physics of the impossible. We are going to ask what the universe looks like when you are faster than the speed of light. We are going to hunt for the tachyon. There is a deep, instinctual belief in the human mind that any barrier can be broken if we simply push hard enough. We are a species of brute force and determination. If a rock is too heavy to lift, we build a lever. If a mountain is in our way, we dig a tunnel. If a distance is too great, we build a faster car. Our intuition, forged in the playground of low-speed Newtonian physics, tells us that speed is cumulative. If you have a rocket that goes 1,000 miles an hour and you strap a second identical rocket to it, you should go 2,000 miles an hour. If you keep adding rockets, keep burning fuel, and keep pushing, you should logically be able to accelerate forever. We assume that the speedometer has no end. We assume that the universe is an open highway where the only limit is how much gas is in the tank. But this intuition is a lie. It is a deception created by the fact that we live our entire lives moving at a snail's pace compared to the cosmos. When you look at the fundamental architecture of reality, you discover that the highway is not open. It ends. There is a wall at the end of the universe, and we are hurtling towards it. This wall is not made of bricks or force fields. It is made of mathematics. It is the infinite wall of the light barrier. To understand why you cannot run faster than light, you have to understand the economy of the universe. In our ordinary world, when you use energy to push an object, that energy is converted into motion. You burn chemical fuel, the engine pistons fire, and the car accelerates. The relationship seems linear. More energy equals more speed. This is true at human speeds. It is even true at the speed of a jet fighter or a bullet. But as you approach the cosmic speed limit, the exchange rate changes. The universe begins to charge a tax on your speed. And this tax is not a fixed percentage. It is a progressive tax that spirals swiftly towards infinity. This phenomenon is governed by the laws of special relativity. Einstein revealed that mass and energy are not distinct entities. They are the same thing in different forms. This is the meaning of the famous equation, E equals mc. 2. Mass is frozen energy. Energy is liberated mass. This equivalence has a terrifying consequence for space travel. When you push an object to make it go faster, you are adding kinetic energy to it. At low speeds, this added energy manifests purely as velocity. But as you get closer to the speed of light, the object becomes saturated with motion. The universe resists, allowing it to go faster. So, what happens to the energy you are pumping into the engines? It doesn't disappear. Instead of making the object move faster, the energy starts to increase the object's effective mass. This is often called relativistic mass. It means that the faster you go, the heavier you get. You are not gaining more atoms, you are not growing physically larger, but your resistance to acceleration is increasing. You are becoming harder to push. Imagine you are pushing a shopping cart. At first, it is empty and easy to move. You start running. But as you reach half the speed of light, it feels as if someone has thrown a bag of cement into the cart. You have to push harder just to maintain your acceleration. You pour more fuel into the engine. You reach 90% of the speed of light. Now, the cart feels like it is filled with lead. You are screaming, burning every ounce of fuel you have, but the speedometer is barely inching forward. The energy that should be making you faster is instead just making you sluggish. It is weighing you down. This is the tax of the universe. At 99% of the speed of light, the tax rate is exorbitant. For every dollar of energy you spend, 99 cents go into increasing your mass, and only 1 penny goes into increasing your speed. The closer you get to the barrier, the worse the deal becomes. Let's look at the numbers, because they are staggering. If you are traveling at 99% of the speed of light, you are incredibly fast, but you are still subluminal. To get from 99% to 99.9%, you have to increase your energy output by a massive amount. You are now 7 times heavier than you were at rest, but you are stubborn. You want to reach the limit. You push to 99.99999%. You are now hundreds of times heavier. To an outside observer, your spaceship is becoming a monstrously heavy object, plowing through space-time like a bulldozer through concrete. At the Large Hadron Collider in Switzerland, we see this reality every day. We accelerate tiny protons to 99.9999991% of the speed of light. To get those protons to that speed, we have to use giant superconducting magnets and consume enough electricity to power a small city. We are pushing these subatomic particles with all the might of human engineering, and yet we can never, ever get them to 100%. We can add more nines to the decimal. We can get to 99. 9, 9, 9, 9, 9, 9, 9, 9%. But we can never reach the integer one. The reason is the vertical asymptote. If you were to graph the energy required to accelerate an object, the line would curve upwards gently at first, and then, as it approaches the speed of light, it would shoot straight up. It becomes a vertical wall. To reach exactly 100% of the speed of light, the equation divides by 0. The math tells us that the mass of the object would become infinite. Think about what infinite mass means. It doesn't just mean very heavy, it means infinitely heavy. It means that to push it even 1 millimeter faster would require infinite energy. Infinite energy is more energy than exists in all the stars, black holes, and radiation of the entire universe combined. Even if you turned every single atom in the cosmos into pure fuel and burned it all in a single instant to power your rocket, you would still not reach the speed of light. You would just get a tiny fraction closer to the limit, while becoming infinitely heavy in the process. This is the solid wall. It is an absolute prohibition enforced by the geometry of space-time. The speed of light is not just a speed, it is a singularity for matter. It is the point where the laws of physics that govern objects' mass, inertia, momentum blow up and cease to function. Matter is fundamentally incompatible with light speed. This leads to a profound realization about the nature of light itself. If matter cannot reach light speed because of mass, then how does light do it? The answer is that light cheats. Photons are massless. They have no stuff in them. They have zero rest mass. Because they have no mass, they do not pay the tax. They do not experience the resistance of the universe. In fact, for a photon, existence is speed. A photon cannot slow down. It cannot stop. From the moment it is born to the moment it dies, it must travel at exactly c. It has no choice. It is compelled by the geometry of the universe to ride the edge of the barrier. For us, however, creatures made of protons, neutrons, and electrons, we are burdened by our substance. We are the children of mass, and because we have mass, we are condemned to the subluminal world. We are trapped in the slower-than-light sector of reality. We can look at the barrier. We can smash our faces against the glass. We can get arbitrarily close to it, but we can never touch it. The speed of light acts as an event horizon for material objects. Just as you cannot escape a black hole, you cannot break the light barrier from below. This limitation is frustrating to the human spirit. It feels like a cage. It means that the stars will always be agonizingly far away. It means that the dream of galactic empires is choked by the sheer vastness of time. But this wall is also a protector, as we will see later. This speed limit is the only thing preserving the sanctity of cause and effect. It is the only thing preventing the universe from descending into chaotic madness, where the past can overwrite the future. The infinite wall tells us that the universe is not continuous. It has hard edges. It has boundaries that cannot be negotiated. It teaches us that our intuition about force and motion is fundamentally flawed. We used to think that with enough power, we could do anything. But relativity teaches us humility. It teaches us that there are places we simply cannot go. So, here we stand. We are in a spaceship, traveling at 99.999% of the speed of light. The engines are screaming with the power of 1,000 suns. The structure of the ship is groaning under the stress of relativistic mass. We are heavier than a planet. We are pushing against the fabric of reality itself. And ahead of us, just a hair's breadth away, is the speed of light. It mocks us. It remains eternally out of reach. We are Zeno's runner, forever halving the distance, but never arriving. The wall is infinite. The tax is absolute. But this raises a haunting question. A question that flips the entire board game over. We know we cannot cross the wall from the left side. We know we cannot start at 0 and accelerate to light speed. But what if we didn't start at 0? What if there are particles that were never slow? What if there are things that live on the right side of the graph? If the barrier is infinite, you cannot climb over it. But maybe, just maybe, you can exist on the other side of it. Maybe the wall is not a dead end, but a mirror. And perhaps, on the other side of the mirror, everything we just learned is reversed. Perhaps there is a world where infinite energy is required not to speed up, but to slow down. Perhaps there is a world where the speed of light is not the maximum, but the minimum. This is the domain of the Tachyon, and to enter it, we must leave the world of matter behind and step into the world of the impossible. We have established that the speed of light is a wall. From our perspective, living in the slow, heavy world of matter, this wall is infinite and unclimbable. We have learned that to accelerate a single electron to the speed of light would require all the energy in the cosmos, and even that would not be enough. The door is locked, and the key has been thrown away. But in the strange and fluid landscape of theoretical physics, a locked door does not always mean there is nothing on the other side. It simply means we cannot go there. It implies a boundary, a separation between two distinct realms. This brings us to one of the most provocative ideas in the history of science. If the equations of relativity forbid us from crossing the barrier, do they forbid existence on the other side of the barrier? The answer, surprisingly, is no. The mathematics of Einstein's special relativity are symmetric. They describe a universe that is divided into three distinct families of particles, separated by the impenetrable veil of light speed. The first family is our family. We call them bradyons, from the Greek word brades, meaning slow. This includes protons, electrons, neutrons, you, me, the Earth, and the stars. We possess a positive rest mass. Our defining characteristic is that we must always move slower than light. We can sit still, we can accelerate, but we can never reach the limit. The second family is the luxons. These are the particles of light itself, photons and gluons. They have zero rest mass. Their defining characteristic is that they must always move at exactly the speed of light. They cannot slow down, and they cannot speed up. They are the barrier itself. But there is a third potential family, a family that lives in the reflection of the mirror. We call them tachyons, from the Greek word tachys, meaning swift. These are particles that exist exclusively on the fast side of the wall. The existence of the tachyon relies on a simple, elegant loophole in the law of the infinite wall. The law states that you cannot accelerate across the barrier. You cannot start at zero and push your way past C. But the law does not say you cannot be past C if you were born there. Think of the speed of light not as a finish line, but as a border between two nations that are at war. The border is heavily fortified. No one from the nation of slow can cross into the nation of fast. The energy required to breach the wall is infinite. However, if you are a citizen of the nation of fast, you were born there. You didn't have to cross the border. You didn't have to accelerate. You simply popped into existence, moving faster than light. For a tachyon, the speed of light is not a destination. It is a point of origin. This creates a reality that is a perfect, distorted mirror of our own. In our world, the speed of light is the absolute ceiling. It is the maximum velocity that can never be attained. In the tachyon world, the speed of light is the absolute floor. It is the minimum velocity. A tachyon cannot slow down to the speed of light. To do so would require infinite energy. Just as we push against the barrier from below, struggling to go faster, the tachyon pushes against the barrier from above, struggling to go slower. We are trapped in the subluminal. They are trapped in the superluminal. If you were to step into the shoes of a tachyon, the laws of physics would feel like a fever dream. Everything we know about motion and energy is inverted. In our familiar experience, kinetic energy is the fuel of speed. If you want to make a car go faster, you step on the gas. You add energy to the system. The more energy you add, the faster you go. If you take your foot off the gas, friction bleeds the energy away, and you slow down. Zero energy means zero motion. For a tachyon, this logic is turned upside down. As a tachyon loses energy, it speeds up. If a tachyon is traveling just slightly faster than light, it has enormous energy. It is heavy and sluggish, burdened by its proximity to the barrier. But as it sheds that energy, it becomes lighter, freer, and faster. If a tachyon were to lose all of its energy, if it were to reach a state of zero energy, it would not stop. It would accelerate to infinite velocity. This is the transcendent state. In our world, a particle with zero energy sits still. In the tachyon world, a particle with zero energy is everywhere at once. It moves so fast that it occupies every point along its trajectory simultaneously. This inversion means that the tachyon is inherently unstable in a way that is difficult for the human mind to grasp. In our world, friction slows us down. If you slide a book across a table, the friction steals its energy and brings it to a halt. But if a tachyon slides through space and encounters friction, say, by bumping into gas or dust, that collision would steal its energy. But because it lost energy, it would accelerate. The faster it goes, the more collisions it has. The more collisions it has, the more energy it loses. And the more energy it loses, the faster it goes. This creates a runaway feedback loop. A tachyon is a particle that is constantly trying to tear itself out of the universe by accelerating towards infinity. It is a fugitive of physics, running away from the speed of light as if the barrier were hot lava. Because of this property, a tachyon cannot remain at rest. In fact, rest is a concept that does not apply to it. We have a rest mass because we can stop. A tachyon has no rest mass because it can never be at rest. It is a creature of pure momentum. It is a shark that must keep swimming, but in this case, the shark is swimming faster than the universal speed limit, and if it tries to slow down, it dies against the wall of light. The existence of such a particle changes how we view the infinite wall we discussed previously. We used to think of the wall as a limit to everything, but now we see it as an asymptote. In mathematics, an asymptote is a line that a curve approaches but never touches. In the graph of the universe, the speed of light is a vertical line in the center. The bradyons are a curve on the left side, rising up towards the line but never reaching it. The tachyons are a curve on the right side, descending from infinity towards the line but never touching it. The wall separates the two populations, ensuring they never meet. This separation explains why we have never seen one. We cannot interact with them because to interact, we would have to be in the same kinematic state. We are ghosts to each other. We are two different fluids in the same jar, separated by density, unable to mix. A tachyon might be passing through your body right now, but it is moving so fast, with such a distinct physical signature, that it does not interact with your atoms. It slips through the gaps of your reality. However, the mirror particle hypothesis suggests that the universe is fuller than we thought. It suggests that the empty void of space might actually be teeming with superluminal activity that is simply too fast for us to catch. It challenges our arrogance. We assume that because we are slow, the universe must be slow. We assume that because we perceive time in a linear, forward progression, all things must follow that rule. But the tachyon mocks that assumption. The most disturbing implication of the tachyon is not just its speed, but its relationship to time. As we will explore later, speed and time are interlocked. If you break the speed limit, you break the timeline. But before we get to the paradoxes of time travel, we have to deal with an even more immediate problem. A problem of existence. If a tachyon exists, what is it made of? We know that mass increases as you approach the speed of light. We know that mathematical term SQRT 1 V 2 C 2 appears in the equations. If V is less than C, the number under the square root is positive, and everything is fine. But if V is greater than C, if you are a tachyon, then V2 is larger than C2. The number under the square root becomes negative, and you cannot take the square root of a negative number, not in the real world. If you type the square root of -1 into a standard calculator, it gives you an error. It says undefined, but the universe is not a standard calculator. The universe uses advanced mathematics. When you take the square root of a negative number, you get an imaginary number. This suggests that the mass of a tachyon is not a real number like 5 kilograms or 10 grams. Its mass is an imaginary number. This sounds like a trick. It sounds like we are just making things up to make the math work. But imaginary in mathematics does not mean fake. It is a specific, well-defined concept. And if tachyons are real, then imaginary mass must correspond to some physical reality. What does it mean to have a mass that is perpendicular to reality? What does it mean to be made of imaginary stuff? We have stepped through the mirror. We have found the particle that lives on the ceiling of the universe. It runs faster as it loses energy. It accelerates towards infinity. It is trapped in a realm where the speed of light is the slowest possible crawl. But to understand how it stays alive, we have to confront the ghost in the machine. We have to understand the strange, ethereal nature of imaginary mass. If you take a standard pocket calculator, type in the number -1 and hit the square root button, you will likely get an error message. The screen might blink E for error, or it might simply say undefined. This is the machine telling you that you have asked a question that has no answer. In the world of basic arithmetic, there is no number that, when multiplied by itself, produces a negative. Positive times positive is positive. Negative times negative is also positive. The negative square is a forbidden zone, a mathematical impossibility. For centuries, this error message was the edge of the map. It was the "here, there be dragons" of the numerical world. But when physicists tried to push the theory of relativity past the speed of light, they ran headlong into this exact error. They found that the mathematics of the universe, just like your calculator, seemed to crash when velocity exceeded the speed of light. To understand the tachyon, and to understand the ghost of mass, we have to look under the hood of Einstein's equations and see exactly where the smoke starts coming from. And then we have to see the daring, almost magical trick that mathematicians use to fix it. The trouble begins with the Lorentz factor. This is the scaling number that tells us how much time slows down and how much mass increases as you go faster. The formula relies on a very specific term, the square root of 1 minus your speed squared divided by the speed of light squared. It sounds complicated, but the logic is simple. If you are sitting still, your speed is 0. 1 minus 0 is 1. The square root of 1 is 1. Everything is normal. If you are moving at half the speed of light, the number inside the square root is still positive. It is a fraction, but it is a real, healthy number. You can take the square root of it. The math works. But now, imagine you are a tachyon. You are moving at twice the speed of light. Now, the term speed squared divided by light squared becomes the number 4. The equation asks you to calculate 1 minus 4. The result is -3. And suddenly, the equation demands that you take the square root of -3. The machinery of relativity grinds to a halt. The calculator explodes. According to the rules of algebra, physical quantities like length, time, and energy are supposed to be real numbers. You cannot have a spaceship that is imaginary 5 meters long. You cannot wait for imaginary 10 seconds, and you certainly cannot possess imaginary kilograms of mass. This is where most people would stop. They would look at the negative sign, declare that faster than light travel is mathematically impossible, and go home. But theoretical physicists are not most people. They looked at this broken equation and they asked, what if we just kept going? What if we used a tool that exists outside of the physical world to solve a problem inside of it. Enter the number I. The number I is the imaginary unit. It is defined, quite simply, as the square root of -1. It is a number that exists sideways to reality. If you think of all the real numbers, 1, 2, 3, pi, a million, as sitting on a horizontal line, the imaginary numbers sit on a vertical line. They are not fake. They are just in a different direction. They are used every day by electrical engineers to calculate alternating currents and by computer scientists to process signals. They are a valid part of the logical structure of the universe, even if you can't count them on your fingers. So, here is the trick. Here is how the tachyon survives the math. If you are moving faster than light, the Lorentz factor becomes an imaginary number. It contains I. If we want the energy of the particle to be a real, measurable thing, something that can hit a detector or burn a sensor, we have a problem, because energy equals mass times the Lorentz factor. If the factor is imaginary and the mass is real, the energy becomes imaginary. And imaginary energy doesn't make sense in our physical universe. To fix this, physicists made a bold assumption. They said, if the Lorentz factor is imaginary, let us assume that the mass is also imaginary. In mathematics, if you multiply I by I, you get -1. You get a real number. Two imaginaries make a real. So, if the tachyon has an imaginary mass and it is moving at an imaginary speed factor, the two ghosts cancel each other out and they produce a real energy. The equation balances. The calculator stops blinking error and spits out a valid answer. This is the definition of a tachyon. It is a particle with imaginary mass. But what does that actually mean? It is easy to say the words imaginary mass, but it is incredibly difficult to picture it. In the material world, mass is a measure of inertia. It is a measure of how hard it is to push something. A rock has mass. It resists being moved. A feather has less mass. It resists less. What does it mean to have imaginary resistance? It does not mean the tachyon is weightless. Weightless particles, like photons, have zero mass. Imaginary mass is something else entirely. It suggests a fundamental instability in the fabric of the particle's existence. Think of a ball. If you place a ball at the bottom of a bowl, it stays there. If you nudge it, it rolls back down. It is stable. This is how normal particles with positive mass behave. They like to be slow. They like to sit at the bottom of the energy valley. They resist acceleration. Now, imagine balancing that ball on the very sharp tip of a needle. It is possible, theoretically, for it to sit there, but it is profoundly unstable. The slightest breath, the tiniest vibration, and it will fall. And once it starts falling, it goes faster and faster. It doesn't want to go back to the top. It wants to get away from the top as quickly as possible. This is the physical interpretation of imaginary mass. A tachyon is like that ball on the needle. It is a bundle of energy that is inherently unstable. Its rest state is a state of crisis. It cannot handle being slow. The math of imaginary mass dictates that the particle is falling through space-time, and that fall manifests as speed. This explains the strange behavior we observed earlier, the fact that tachyons speed up as they lose energy. In our familiar world, structure requires energy to maintain speed against resistance. But for an object with imaginary mass, the structure of the physics is inverted. the math of the imaginary number I introduces a negative sign into the momentum equation. This negative sign acts like a mirror, flipping the relationship between cause and effect in terms of force. When you push a tachyon to try to slow it down, the imaginary mass reacts by translating that push into acceleration. It behaves contrary to intuition because it is built of geometry that is perpendicular to our own. We must clarify that imaginary is a terrible name. It was chosen by René Descartes centuries ago as a bit of an insult to these strange numbers, and the name stuck. A better name might be lateral mass or complex mass. It is not a fiction. It is a description of how the particle couples to the Higgs field. In modern physics, mass is not a property you are born with. It is a property you acquire by swimming through the Higgs field. Protons and electrons swim through this field like it is molasses, and that drag gives them mass. Photons slip through it like it isn't even there, remaining massless. Tachyons, if they exist, interact with the field in a way that is mathematically rotated by 90 degrees. They don't just swim, they slide in a way that generates a negative feedback loop. They are allergic to the field. The field repels them, spitting them out at speeds exceeding light. This ghost of mass is why we cannot simply catch a tachyon and put it in a box. If you tried to confine a tachyon, you would be trying to force it to be still. But as we know, to be still is to have infinite energy. A boxed tachyon would be a bomb of infinite power. The moment you try to pin down the ghost, it explodes with the force of a universe. Its nature is to flee. Its mass is not a measure of substance, but a measure of its need to escape. The concept of imaginary mass also solves the paradox of the energy wall. Remember the infinite barrier at the speed of light? For normal matter, the curve goes up to infinity. For tachyons, the curve comes down from infinity. The two curves meet at the speed of light, but they never cross. The imaginary mass ensures that the tachyon remains on its side of the reflection. It creates a kinematic quarantine. So, when we look for tachyons, we are not looking for tiny rocks or billiard balls. We are looking for ripples in the math. We are looking for evidence of this ghost mass. We are looking for equations that only balance if we include the square root of -1. It is a humbling realization. We tend to think of the universe as being made of solid, tangible stuff. But at the deepest level, the universe is made of math. The fact that we can even conceive of imaginary mass and that we can write down consistent laws for it suggests that reality is far more flexible than our senses allow us to perceive. We are stuck in the real number operating system, but the hardware of the cosmos might be running on complex numbers. The tachyon is the avatar of this hidden complexity. It is the ghost that haunts the equations, whispering to us that there is more to mass than just weight. It tells us that mass can be a direction. It tells us that mass can be a vector pointing into a dimension we cannot see. And it warns us that if we ever find a way to interact with this ghost, we will have to rewrite the rules of energy itself. We have established that tachyons are born fast, that they speed up as they lose energy, and that they are made of this strange, ethereal, imaginary mass. But this is just the static description of the particle. The true madness begins when we let this particle move. When a ghost moves faster than the speed of light, it doesn't just break the speed limit. It begins to shatter the concept of energy itself. It leads us to the energy paradox, where the very act of existing becomes a race against zero. Consider the simple, intuitive act of driving a car. You sit in the driver's seat, You press your foot down on the accelerator, and the engine roars. You are converting chemical energy into kinetic energy. The more gas you burn, the faster the wheels spin. If you want to reach 100 miles an hour, you have to pay for it with fuel. If you take your foot off the pedal, the car coasts, friction takes over, energy bleeds away, and you eventually come to a stop. This is the fundamental contract of our existence. Motion requires effort, and stillness is the natural state of things. We live in a universe where speed is expensive, but we have now crossed the mirror. We have entered the realm of the tachyon, and in this inverted reality, that contract is torn into pieces. The laws of thermodynamics and mechanics are not just bent, they are reversed. In the tachyon world, speed is not a luxury you pay for. Speed is the desperate, inevitable result of poverty. In the tachyon world, you do not need energy to go fast. You need energy to stop. To understand this paradox, we have to look at the landscape of energy relative to the speed of light. Imagine the speed of light as the peak of a terrifyingly high mountain. We, the people of matter, live in the valley on the left side of the mountain. We are at the bottom, sitting at rest. If we want to climb up towards the peak towards light speed, we have to expend massive effort. We hike, we climb, we struggle against gravity. The higher we get, the steeper the slope becomes. As we approach the summit, the slope becomes a vertical wall. We can pour infinite energy into our climb, but we can never quite pull ourselves over the top. We slide back down to the valley of slow. The tachyon lives in the valley on the right side of the mountain. But here is the twist. For the tachyon, the bottom of the valley is infinite speed. The top of the mountain is still the speed of light. This means that for a tachyon, to approach the speed of light is to climb a vertical wall. It has to fight. It has to gain energy. It has to become heavier and more distinct to slow down enough to even glimpse the speed of light. The barrier of C acts as a repulsive force. It pushes us down towards rest, and it pushes tachyons down towards infinity. This creates the energy paradox. In our world, a bullet traveling at twice the speed of sound has more energy than a bullet traveling at the speed of sound. It hits harder, it destroys more. But in the tachyon world, a particle traveling at 1 billion times the speed of light has less energy than a particle traveling just barely faster than light. Let that sink in. The faster a tachyon goes, the less energy it has. If a tachyon were to accelerate all the way to infinite velocity, if it were to move so fast that it crossed the entire universe in literally 0 time, its energy would drop to exactly 0. It would become a phantom. It would have velocity, but no punch. This completely rewrites our understanding of propulsion and inertia. Imagine you are the captain of a starship built of tachyons. You are currently cruising at twice the speed of light. This is your slow speed. You want to go faster. In a human ship, you would fire the rockets behind you to push forward. But in a tachyon ship, firing the rockets adds energy to the system. And for you, adding energy means moving towards the barrier. Adding energy slows you down. If you fire your engines, your ship will scream and shudder and brake hard, dragging itself down towards the speed of light. To go faster, you have to do the opposite. You have to throw energy overboard. You have to apply the brakes to speed up. You need to bleed energy out of your hull, radiate heat, and dump fuel. As you lose that energy, the grip of the light speed barrier loosens, and you shoot forward. The more empty you become, the faster you fly. The ultimate destination of every tachyon is to shed every ounce of energy it possesses and dissolve into the infinite speed of the void. This leads to a terrifying instability known as the runaway feedback loop. In physics, nature tends to seek the lowest energy state. A ball rolls to the bottom of a hill. Hot water cools down to room temperature. Everything wants to lose energy. We call this entropy. For us, losing energy means coming to a halt. It is a peaceful death of motion. But for a tachyon, the lowest energy state is infinite velocity. This means that tachyons are naturally suicidal speedsters. They want to lose energy, and the universe is full of ways to lose energy. Consider a tachyon flying through the vacuum of space. Even space isn't truly empty. It has dust, gas, and quantum fields. When a charged particle moves through a medium faster than light can move in that medium, it emits a ghostly blue glow called Cherenkov radiation. We will explore the visual beauty of this later, but right now, focus on the energy cost. Radiating light costs energy. So, a tachyon is flying along. It emits a photon of Cherenkov radiation. This means the tachyon has lost a tiny bit of energy. Because it lost energy, the laws of the tachyon world dictate that it must speed up. Now it is going faster. Because it is going faster, it interacts more violently with the field, and it radiates more energy. Because it radiates more energy, it loses more energy. Because it loses more energy, it goes even faster. You can see the catastrophe. It is a chain reaction that happens instantly. The moment a tachyon is born, if it interacts with anything at all, it will instantly dump all of its energy in a blinding flash and accelerate to infinite speed. It vanishes from our local reality effectively the moment it appears. It doesn't just run away, it falls out of the energetic universe. This paradox suggests that tachyons might be impossible to detect, not because they are rare, but because they are too fast for the concept of detection to apply. To detect a particle, you usually have to catch it, or at least bump into it. You need it to hit your sensor and transfer some energy. But a high-speed tachyon has almost zero energy. It is a weak particle. A tachyon, moving at 1,000,000,000,000 times the speed of light, is so energetic poor that it might pass through the entire Earth without knocking a single electron out of orbit. It is a ghost in the truest sense, present but impotent. Conversely, the most dangerous tachyon is the slow one. A tachyon moving just 1% faster than light carries nearly infinite energy. If you were hit by a slow tachyon, it would strike with the force of an exploding star. But nature protects us from this. Because slow tachyons have such high energy, they are incredibly unstable. They desperately want to shed that energy and speed up. A slow tachyon would likely decay into a fast tachyon and a shower of other particles almost instantly. The dangerous monsters evolve into harmless ghosts before they can hurt us. There is a philosophical beauty to this arrangement. The universe seems to enforce a strict segregation between the two realms. On our side of the wall, we hoard energy to gain speed, but we can never win the race. On their side, they shed energy to gain speed, but they fade into nothingness as they do so. This creates a vision of the cosmos that is far stranger than the clockwork machine of Newton. We tend to think of being real as having substance, mass, and energy. We think that zero energy means non-existence. But the tachyon challenges this definition. The zero-energy tachyon, the one moving at infinite speed, is a valid solution to the equations. It is a particle that exists as pure geometry, a connection between 2 points in the universe that happens instantaneously, yet carries no force. It is a transcendent particle. It suggests that space and time are woven with threads that we cannot pull. We are used to pulling threads that have weight-moving rocks, building bridges, but there may be other threads that are frictionless, timeless, and massless. The energy paradox also helps to resolve one of the biggest headaches of faster-than-light travel in science fiction. In movies, when the ship goes to warp speed, the engines roar with power, the lights flicker, the reactor groans. This assumes that superluminal travel requires super energy, but the physics of the tachyon suggests the opposite. The warp drive wouldn't need a massive power plant to maintain high speed. It would need a massive power plant to start the journey and punch through the wall. But once on the other side, the ship would need to shut down everything to go faster. The pilot would cut the engines to cross the galaxy. Silence would be the sound of speed. This inversion of logic is the hallmark of the tachyon. It forces us to rethink the definitions of fast and strong. In our intuition, a speeding bullet is strong, a floating feather is weak. In the tachyon world, the speeding bullet is the feather-light, wispy, barely there. The slow, lumbering crawl near the speed of light is where the iron weight lies. As we stare into this paradox, we realize that the concept of energy is not a universal constant of value. It is relative. It depends on which side of the mirror you are standing on. We value energy because it allows us to move. Tachyons despise energy because it holds them back. But there is a catch. If a tachyon loses energy and speeds up, where does that energy go? It has to go somewhere. It turns into light. It turns into radiation. And even though the tachyon itself might be invisible to our eyes, its footprint is not. A particle breaking the cosmic laws leaves a trail. It leaves a shock wave. Just as a jet plane breaking the sound barrier creates a sonic boom that rattles windows, a particle breaking the light barrier creates a photonic boom. We cannot see the ghost, but we might be able to see the wake it leaves in the water. We might be able to see the blue glow of a possible traveler. This is our best hope for finding them. We must look for the light that shouldn't be there. We must look for the blue boom. Imagine standing in the middle of a vast, flat desert. The air is still, the sun is hot, and the silence is absolute. Suddenly, without any warning, a fighter jet screams overhead. But here is the strange part. You see the jet pass you in complete silence. It traces a line across the sky, mute as a ghost. It is only seconds later, after the plane is already miles away, that the sky is ripped apart by a deafening crack of thunder. A boom so powerful it rattles your bones. This is a sonic boom. It happens because the jet is traveling faster than the sound waves it is creating. The sound cannot get out of the way. It cannot propagate forward because the source is moving faster than the message. So, the sound waves pile up on top of each other, compressing into a single, violent shockwave that trails behind the aircraft like the wake of a boat. The boom is the sound of the air panicking, trying to obey the laws of physics in the presence of an object that is moving too fast for the atmosphere to handle. We understand this phenomenon intuitively with sound. We know that the sound barrier is a physical wall of pressure, but light is a wave too. Light behaves like sound in many ways. And just as a jet can break the sound barrier, a particle can break the light barrier. When it does, it doesn't create a sonic boom. It creates a photonic boom. It creates a shockwave of luminosity. If you were standing in the deep ocean and a faster-than-light particle flew past you, you wouldn't hear a crack. You would see a ghostly, glowing cone of blue light. This is not science fiction. This is a very real, very beautiful phenomenon known as Cherenkov radiation. It is named after the Soviet physicist Pavel Cherenkov, who won the Nobel Prize for explaining it. And it is the most vital tool we have in the hunt for the tachyon. To understand how this works, we have to clarify a loophole in the laws of the universe. We have said repeatedly that nothing can travel faster than the speed of light in a vacuum. That speed, c, is the absolute limit. However, light does not always travel through a vacuum. Sometimes it travels through water or glass or ice. When light enters a dense medium like water, it slows down. The photons interact with the electrons in the water molecules, getting absorbed and re-emitted, effectively bouncing around in a chaotic dance. In water, light slows down to about 75% of its vacuum speed. This creates a fascinating opportunity. A particle of matter, like an electron, can enter that water, traveling at 99% of the speed of light. Because the electron is heavy and punches through the water molecules without getting absorbed, it doesn't slow down as much as the light does. In this specific environment, the electron is moving faster than the light around it. It is outrunning its own image. It is a local speedster, breaking the local light barrier. When this happens, the electromagnetic field around the electron cannot propagate forward fast enough. The electric field lines pile up, just like the air pressure in front of the jet. They form a cone-shaped shockwave behind the particle. This shockwave releases energy in the form of photons. Because the wavefront is so steep and energetic, these photons are pushed into the high-frequency end of the visible spectrum. They appear as a piercing, electric blue or violet glow. If you look into the core of an active nuclear reactor, submerged in its cooling pool, you will see this light. It glows with an eerie, beautiful sapphire luminescence. That is not a special effect. That is the visual scream of subatomic particles breaking the local speed limit of the water. It is the sonic boom of light. Now, let us apply this to the tachyon. If tachyons exist, they are always traveling faster than light in a vacuum. This means they are definitely traveling faster than light in a medium. A tachyon passing through a block of glass, or a tank of water, or even the atmosphere of the Earth would be moving massively faster than the photons in that environment. This means that if tachyons carry an electric charge, they should be glowing. They should be permanent generators of Cherenkov radiation. This is how we hunt them. We do not look for the particle itself, because it moves too fast to capture. We look for the wake it leaves behind. We build massive tanks of water, buried deep underground to shield them from cosmic rays, and we line the walls with thousands of sensitive light detectors. These are the same observatories we use to catch neutrinos. We wait in the dark, watching the water, looking for a specific pattern of blue light that would indicate a particle moving faster than c. But detecting a tachyon is not as simple as seeing a blue flash. The geometry of a tachyon's passage would look incredibly strange to a human observer. Because the object is moving faster than the information it transmits, the sequence of events is scrambled. Imagine a tachyon is flying straight towards you. Because it is faster than light, it arrives at your eyes before the image of it leaving its starting point. You would not see it approaching. The space in front of you would look empty. Then, suddenly, the tachyon would pass you. At that exact moment, you would see a flash of light appear out of thin air right in front of your face. This is where it gets trippy. As the tachyon moves away from you behind your back, the light from its approach is finally catching up to you. Simultaneously, the light from its departure is reaching you. To your eyes, that single flash would split into two images. One image would appear to move forward, traveling away from you in the direction the particle actually went. The other image would appear to move backward, retreating to the point of origin. You would see the same particle appearing to travel in two opposite directions at once, originating from a single point in space. This is the double image effect of superluminal travel. It is a visual hallucination caused by the fact that the object is outracing its own history. If a tachyon spaceship flew past Earth, astronomers wouldn't see a ship zooming by. They would see a sudden explosion of light that splits into two ships, one flying forwards and one flying backwards, like a movie reel being played in both directions simultaneously from the middle. There is another layer to this detection method that links back to the energy paradox we discussed earlier. Remember that for a tachyon, losing energy makes it go faster, and emitting Cherenkov radiation costs energy. The blue glow is energy leaving the particle. This implies that a charged tachyon is a doomed entity. As it flies through the universe, it emits this blue shockwave. This emission drains its energy. As its energy drains, it accelerates. As it accelerates, it emits the radiation even more violently. This creates a catastrophic feedback loop. A charged tachyon should theoretically vaporize its entire energy reserves in a fraction of a second, appearing as a blindingly bright flash of blue light that instantly accelerates to infinite speed and vanishes. This tells us something crucial about what we should be looking for. We shouldn't be looking for a stable trail of bubbles in a detector. We should be looking for a blue boom, a sudden, unexplained pulse of ultraviolet radiation that appears out of nowhere and has no identifiable source. This phenomenon also acts as a constraint on our theories. If charged tachyons were common, the night sky wouldn't be dark. The universe would be filled with the background hiss of these particles screaming through the cosmos, dumping their energy into blue light. The vacuum of space would be glowing. The fact that the sky is dark tells us something important. Either tachyons do not exist, or they are exceedingly rare, or, and this is a distinct possibility, they are electrically neutral. If a tachyon has no electric charge, like a neutrino, it would be invisible. It would not interact with the electromagnetic field. It would not create a shock wave. It could pass through the earth, through the water tanks, and through your body without leaving a trace. It would be a silent flyer, a stealth jet that breaks the barrier without making a boom. However, even neutral particles can interact via gravity or the weak nuclear force. We look for indirect evidence. We look for collisions where energy seems to appear before the collision happens. We look for tracks in particle accelerators that bend the wrong way. The concept of the blue boom is a reminder that the laws of physics are not just abstract equations, they are sensory experiences. Breaking a law of nature usually results in a violent protest from the environment. The sonic boom is the air protesting the speed of the jet. The Cherenkov glow is the electromagnetic field protesting the speed of the particle. The universe does not like to be outrun. It reacts. It flares up. So, the next time you see a picture of a nuclear reactor glowing with that deep, mesmerizing blue, remember what you are looking at. You are seeing the shadow of the impossible. You are seeing light itself losing a race. And somewhere in the vast databanks of our underground observatories, hidden among billions of signals, we are hoping to find that one specific flash, that one double-headed streak of light that proves we are not locked in this cage of speed forever. We are looking for the footprint of the ghost, but detecting the particle is only the beginning. If we were to actually find one, or worse, if we were to catch one and harness it, we would face a problem far greater than a blue glow. We would face a problem that threatens the very foundation of logic. Because if you can move faster than light, you are not just moving through space, you are moving through time. And that is where the real danger begins. Up until this moment, we have been talking about speed as a measure of distance. We ask, how long does it take to get from New York to London? Or how many years to get from Earth to Mars? We treat space as a map and speed as the tool we use to cross it. But this is a primitive, three-dimensional way of thinking. In the eyes of physics, specifically within the framework of Einstein's relativity, speed is not just about traversing space. Speed is a rotation into time. If you understand only one thing about the universe, let it be this: space and time are not separate things. They are woven together into a single fabric called space-time. When you move through space, you are trading your motion through time. If you stand perfectly still, you are moving through time at the maximum possible rate, 1 second per second. But the faster you move through space, the slower you move through time. You are effectively borrowing from your future to pay for your present velocity. This is why astronauts age slightly slower than people on Earth. But there is a terrifying corollary to this rule. If moving at the speed of light stops time, and moving near the speed of light slows time, then what does moving faster than the speed of light do? The geometry of relativity gives us a clear, unambiguous, and haunting answer. If you run fast enough, you do not just stop time, you reverse it, you catch up to yesterday. This brings us to the most dangerous theoretical device in all of physics, the tachyonic anti-telephone. The name sounds whimsical, almost like a joke from a vintage comic book, but the concept was taken very seriously by Albert Einstein and his colleagues. It is a thought experiment designed to show that if tachyons exist, they are not just fast particles, they are time machines. And the moment you introduce a time machine into a universe governed by cause and effect, reality begins to crack. To understand how the anti-telephone works, we have to let go of the idea of a universal now. We tend to believe that now is the same for everyone. If it is 12 p.m. for me, it is 12 p.m. for you, and 12 p.m. for a biological slime mold on Alpha Centauri. But relativity killed this idea. Now is relative. It depends entirely on your speed. Imagine time is a loaf of bread. You slice the bread to separate the past from the future. The slice you are currently holding is now. If you and I are standing still, we cut the bread at the same angle. We agree on what is happening at this moment. But if I get in a spaceship and fly past you at near the speed of light, my angle changes. My motion causes my slice of the universe to tilt. Because my slice is tilted, what I consider to be now might be what you consider to be next week. Or, if I am moving towards you, my now might be your last week. This is normally fine because light is slow enough that we can never exchange information fast enough to exploit this difference. The speed of light acts as a chaperone. ensuring that even though our clocks disagree, we can never talk to each other out of order. But the tachyon ignores the chaperone. The tachyon moves so fast that it can travel along these tilted slices of time instantly. Let us build the machine. Imagine two observers, Alice and Bob. Alice is on Earth. Bob is in a spaceship moving away from Earth at 80% of the speed of light. They both possess a device capable of sending and receiving tachyons. This is the anti-telephone. Alice wants to send a message to Bob. She types "hello" into her computer at noon. The transmitter fires a burst of tachyons. Because tachyons travel faster than light, they cross the distance to Bob's ship almost instantly. Let's say the signal reaches Bob 1 second later by Alice's clock. So far, this just sounds like a very fast text message. But here is the trick. Because Bob is moving away from Alice at incredible speed, his perception of time is tilted relative to hers. In Bob's reference frame, events on Earth appear to be shifted. Due to the geometry of his motion, the moment Alice sent the message is mathematically located in his past. But the trajectory of the tachyon, because it is superluminal, allows it to bridge that gap in a way that defies logic. Bob receives the message. He looks at his clock. Now, Bob decides to reply immediately. He types "message received" and fires his own tachyon beam back at Earth. This is where the universe breaks. The tachyons leaving Bob's ship are moving faster than light relative to him, but Bob is already moving at 80% of light speed away from Alice. When you combine the velocity of the ship with the negative time trajectory of the tachyon caused by the tilt in space-time, the return signal does not just go back to Earth, it travels back in time relative to Earth. The math is inescapable. If Bob is moving fast enough and the tachyons are fast enough, the reply signal will travel down the timeline. It will arrive at Alice's laboratory at 11 a.m. Alice sits at her desk. It is 11 a.m. Suddenly, her computer beeps. A message appears on the screen. Message received. She stares at it, confused. She hasn't sent the message yet. She won't send the hello message until noon, 1 hour from now. But she already has the reply. This is the tachyonic anti-telephone. It is a device that allows you to receive answers to questions you haven't asked yet. It allows you to read tomorrow's newspaper today. It connects the future to the past in a loop that bypasses the present. The implications of this are not just about communication. They are about the structure of destiny. If Alice receives a message from the future saying, "Do not buy the stock," she can choose not to buy it. But if she doesn't buy it, the events leading to the message might change. Does the message vanish? Or is she locked into a future she has already seen? This thought experiment strips away the safety of the speed limit. We often think the speed limit is there to keep us from reaching the stars too quickly. But the existence of the anti-telephone suggests the speed limit has a much more fundamental job. It is there to protect history. It is the firewall that prevents the future from hacking the past. If tachyons exist, then the distinction between past, present, and future is merely a stubborn illusion. A tachyon makes the timeline transparent. It turns the universe into a block of solid glass, where every event, your birth, your death, the beginning of the world, and the end of the universe exists simultaneously, accessible to anyone with a fast enough transmitter. Think about the chaos this would unleash. In our current reality, we operate on imperfect information. You bet on a horse because you hope it will win. You propose marriage because you hope they will say yes. We live in a world of probability. The anti-telephone destroys probability. It replaces hope with certainty. If you can send a tachyon back from 5 minutes in the future, you can win every lottery. You can avoid every accident. You can cure every disease before it starts. But you can also destroy the logic of your own existence. If Alice receives the reply at 11 a.m., she technically has the free will to decide not to send the original message at noon. She can look at the reply, fold her arms, and wait. So, if she doesn't send the hello, how did Bob receive it? And if Bob didn't receive it, how did he send the reply? And if he didn't send the reply, how is it on Alice's screen? The anti-telephone is not just a phone, it is a paradox generator. It creates a closed time-like curve, a loop in causality that has no beginning and no end. The information, message received, exists in the universe without ever having been created. It is an orphan of logic. This is why Einstein called this spooky. It wasn't just that the math was weird. It was that the math seemed to allow for magic. The anti-telephone suggests that if you can move faster than light, you are effectively distinct from the flow of the universe. You are an observer standing outside of time, watching the film reel of reality, able to cut and splice the tape at will. Most physicists look at the anti-telephone and use it as proof that tachyons cannot exist. They argue that the universe is a rational place, and a rational place does not allow you to kill your own grandfather or receive emails from next Tuesday. They say that causality is a stronger law than relativity. They believe that the universe would sooner destroy a tachyon than allow a paradox to occur. But there is another possibility, a darker one. Perhaps tachyons do exist, and perhaps the anti-telephone is possible. And perhaps the reason we haven't seen any time travelers, and the reason we haven't received any messages from the future, is because the moment you turn the machine on, reality collapses. Maybe the protection isn't a law of physics, but a catastrophic failure of the system. The connection between speed and time is absolute. You cannot have one without the other. If you break the speed limit, you break the clock. And if you break the clock, you break the story. The tachyon is the only character in the cosmic play that can read the script ahead of time. And as we are about to see, when the actors start rewriting the script while the play is still running, the entire theatre is in danger of burning down. This leads us to the ultimate nightmare of faster-than-light travel. It leads us to the death of cause and effect. The universe, as we understand it, is built on a foundation of stories, not fairy tales or myths, but sequences of events that follow a strict, unbreakable logic. A cup falls off the table, hits the floor, and shatters. The fall is the cause, the shattering is the effect. The shattered glass never leaps back onto the table to become whole again. You never hear the crash before you push the cup. This sequence cause leading to effect is known as causality. It is the arrow of time. It is the rule that ensures reality makes sense. It allows us to make plans, to learn from mistakes, and to do science. It tells us that the past is the solid ground upon which the future is built. But if tachyons exist, and if they can truly travel faster than light, then they are not just breaking the speed limit, they are breaking the story. They are taking the arrow of time and snapping it over their knee. They introduce the terrifying possibility that the effect can happen before the cause. And once you allow that to happen, even once, the logic of the entire universe begins to collapse. Let's go back to the idea of the phone call to yesterday. Imagine you are holding a tachyonic transmitter. You have the power to send a signal back in time by 1 hour. This seems like a superpower. You could send stock tips, warnings, or lottery numbers. But let's make the stakes higher. Let's make it a matter of life and death to expose the true horror of the paradox. Imagine you are walking down the street at noon. You see a car lose control and swerve towards you. In our normal timeline, you might be hit, but in this tachyonic world, you have a failsafe. You have a computer system set up at home. It is programmed with a simple instruction. If I am hit by a car at 12 p.m., send a message back to me at 11 a.m. saying, "Don't walk down that street." So, the accident happens. The sensor triggers. The tachyon beam fires back through time. You, at 11 a.m., receive the message. You read it. Don't walk down that street. You obey the warning. You stay home. You sit on your couch, safe and sound. Here is where reality breaks. If you stayed home at 11 a.m., then you were never on the street at 12 p.m. If you were never on the street, you were never hit by the car. If you were never hit by the car, the computer never triggered. If the computer never triggered, the message was never sent. If the message was never sent, you didn't receive the warning at 11 a.m. If you didn't receive the warning, you did walk down the street. And if you walked down the street, you got hit and the message was sent. We are trapped in an infinite loop of logic that has no resolution. You are both dead and alive. The message is both sent and unsent. This is not just a riddle. This is a fatal error in the operating system of existence. It is the grandfather paradox, stripped of its human element and reduced to pure information. In physics, we can deal with uncertainty. Quantum mechanics tells us that a particle can be in two places at once until we measure it. But this is different. This is a logical contradiction. A thing cannot be true and false at the same time in the same way. The universe, which is fundamentally a mathematical structure, cannot solve the equation. A causes B, which prevents A. It is a snake eating its own tail, choking on it, and dying. If faster than light, FTL, travel is possible, then every single event in the cosmos becomes suspect. If a tachyon can arrive before it was sent, then the future can influence the past. This means that the history of the universe is not a fixed record. It is a shifting, unstable fluid. The dinosaurs might be extinct today, but if a random burst of tachyons from a supernova a billion light-years away hits the Earth in the Jurassic period, history could be rewritten. The ground beneath our feet is not solid. This leads to the concept of the death of causality. If causality dies, science dies with it. Think about how we learn things. We observe a phenomenon, we propose a cause, and we test it. We light a match, and we see fire. We say, friction caused the heat, which caused the ignition. But in a universe with tachyons, the fire could appear before you strike the match. The building could burn down because someone was going to drop a cigarette an hour later. How can you study a universe where the answers arrive before the questions? Logic evaporates. The universe becomes a chaotic hallucination where things happen for no reason or for reasons that haven't occurred yet. Physicists despise this idea. It is so repulsive to the scientific mind that Stephen Hawking proposed a chronology protection conjecture. He suggested that the laws of physics are rigged to prevent time travel. He believed that the universe hates a paradox so much that it will intervene to stop it. In our car accident scenario, Hawking's conjecture suggests that something would go wrong. The tachyonic transmitter would blow a fuse, the message would be garbled, you would misread the text. Or, in a darker twist, maybe you receive the message, "Don't walk down the street," and you get so scared that you run out of your house in a panic and run into the path of the car, thereby causing the very accident you tried to avoid. This is the idea of the self-fulfilling prophecy. It suggests that the timeline is rigid. You can send information to the past, but you cannot change it. The past is already written, and your attempt to change it is just part of the ink. But even this solution is horrifying in its own way. It implies that we have no free will. It implies that we are puppets acting out a script that has already been filmed. If you receive a message from the future, you are enslaved by it. You are forced to fulfill the loop. There is another solution, one often explored in science fiction, the many worlds interpretation. This theory suggests that when you send the tachyon back to 11 a.m., you are not sending it to your past. You are sending it to a different timeline. In timeline A, you get hit by a car. You send the message. The message arrives in timeline B. In timeline B, the alternate version of you gets the warning, stays home, and survives. Both timelines exist. There is no paradox, only a branching tree of realities. This saves logic, but it kills the meaning of the action. If you save the you in timeline B, you haven't actually saved yourself. You are still bleeding on the pavement in timeline A. The warning went to a stranger who looks like you. You haven't changed the past. You've just created a new future somewhere else. The most disturbing implication, however, brings us back to the nature of the tachyon itself. Remember, tachyons are born fast. They cannot slow down. If the universe truly protects causality, then it must forbid the existence of tachyons entirely. It suggests that the speed of light limit is not about mass or energy or geometry. It is about order. The speed limit exists to keep the pages of the book in the right numbers. It exists to ensure that the beginning happens before the end. If tachyons were to be discovered, if we were to turn on a detector tomorrow and see that blue flash of Cherenkov radiation, it would mean that our faith in a rational, ordered universe is misplaced. It would mean that cause and effect is just a local suggestion, not a universal law. It would mean that reality is far more fragile than we dare to imagine. Imagine a universe where the window breaks 5 minutes before the stone is thrown. Imagine a universe where the wound heals before the knife cuts. Imagine a universe where you remember memories of things you haven't done yet. This is the world of the tachyon. It is a world of madness. And perhaps this is why we haven't found them. Perhaps the silence of the cosmos is not empty. Perhaps it is a filtered silence. Maybe tachyons do pop into existence, but the moment they threaten to create a paradox, the universe deletes them. Maybe the instability of the tachyon isn't just about energy, it's about existential validity. This brings us to the edge of theoretical physics. We are looking at a particle that breaks the rules of the game, but what if the tachyon isn't a thing at all? What if it's a symptom? In quantum field theory, particles are just excitations of a field. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. So, what is a tachyon a ripple of? The answer might lie in the concept of the false vacuum. It is possible that tachyons are not travelers causing chaos, but rather warning signs that the fabric of space-time itself is about to snap. They might not be the assassins of causality. They might be the heralds of a much deeper, much more catastrophic transformation of the universe. To understand this, we have to stop thinking of tachyons as bullets fired from a gun and start thinking of them as a ball rolling down a hill that has no bottom. We must enter the domain of field theory. We have spent a great deal of time treating the tachyon as a traveler. We have imagined it as a tiny, invisible bullet racing through the cosmos, breaking speed limits, glowing with blue light, and rewriting history. We have looked for it in the deep water of our observatories and in the high-energy collisions of our particle accelerators. We have treated it as a distinct object, something that you could theoretically catch, bottle, or map. But what if we are looking at this entirely the wrong way? What if the tachyon is not a particle at all? What if it is a symptom? In the deepest, most fundamental description of our reality, quantum field theory, the universe is not made of hard little marbles. It is made of fields. These are invisible, fluid-like mediums that fill every inch of space and time. An electron is not a solid ball. It is a ripple in the electron field. A photon is a ripple in the electromagnetic field. When the field is calm, space is empty. When you slap the field and make it vibrate, a particle is born. In this framework, the mass of a particle is determined by the shape of the field's potential energy. You can visualize this shape as a landscape. For a normal particle, like an electron, the landscape looks like a valley. The field likes to sit at the bottom of the valley, where the energy is zero. If you add energy, if you kick the field, it rolls up the side of the valley, wobbles back and forth, and eventually settles back down to the bottom. This wobbling is what we call a stable particle. It has positive mass. It requires energy to exist. But when physicists write down the equations for a tachyon, the landscape changes. The imaginary mass of the tachyon does not describe a valley, it describes a hill. Imagine taking a ball and placing it perfectly on the very peak of a sharp, steep mountain. In that exact mathematical center, the ball is motionless. It has zero kinetic energy, but it is in a state of supreme crisis. It possesses tremendous potential energy. It is technically at rest, but it is not stable. The slightest breeze, the tiniest quantum fluctuation, and the ball will not just move, it will fall. It will roll away from the center, gaining speed, losing potential energy, and crashing down towards the bottom. In the language of field theory, a field that looks like a hill is called a tachyonic field, and the particle associated with that field, the tachyon, is not a traveler, it is a glitch. It represents the ball sitting at the top of the hill. The existence of a tachyon in the math is the universe screaming, "I am in the wrong place. I am unstable. I am about to crash." This changes everything. It means that if we were to actually see a tachyon, we wouldn't be seeing a ship from the future. We would be seeing a crack in the hull of the universe. We would be witnessing a region of space that is frantically trying to rearrange itself because it is stuck in a high-energy, unstable state. This leads to a phenomenon with the terrifying name of tachyon condensation. It sounds like dew forming on morning grass, but it is actually a cosmic catastrophe. If a field exists in a tachyonic state at the top of the hill, it cannot stay there. It must roll down. As the field rolls down the hill, the value of the field changes everywhere in space. It floods the universe with a distinctive energy. This rolling down process is a phase transition, exactly like water freezing into ice. When water freezes, it changes its properties. It becomes solid, it expands, When a tachyonic field rolls down, it changes the laws of physics. We know this can happen because it has happened. In fact, you are alive today because of a tachyon. In the very first moments of the Big Bang, the universe was hot, symmetric, and massless. In this primordial epoch, a specific field, the Higgs field, was sitting at the top of its hill. It was in a tachyonic state. The universe was unstable. It was a false vacuum. Then, a fraction of a second after the beginning of time, the balance broke. The ball rolled down. The Higgs field underwent tachyon condensation. It crashed from the top of the potential hill to the stable valley at the bottom. As it crashed, it released an ocean of energy that permeated the entire cosmos. This new, stable field, the condensate, clung to all the other particles. It grabbed the electrons and the quarks and dragged on them, giving them mass. The tachyon that existed at the top of the hill disappeared. It was replaced by the stable, heavy particle we know today as the Higgs boson. In a very real sense, the Higgs boson is the corpse of a tachyon. It is what remains after the instability has resolved itself. The tachyon was not a thing that lived. It was the process of the universe falling into place. It was the spark of the transition. So, when we ask, do tachyons exist? The answer from field theory is complex. They existed for a moment, and their death created the material world. But do they exist now? This brings us to the nightmare scenario known as vacuum decay. We assume that the Higgs field has hit the absolute bottom of the hill. We assume we are in the true vacuum, the most stable possible state of reality. But what if we are wrong? What if the valley we are sitting in is not the bottom of the ocean, but merely a small depression on the side of a much larger cliff? What if we are stuck on a ledge, and far below us, there is a deeper, more stable valley? If this is true, then our entire universe is effectively a tachyonic state waiting to happen. We are the ball balancing on a lower, secondary peak. We are metastable. We are stable for now, but not forever. If a single point in the universe were to suddenly tunnel through the ledge, if a quantum fluctuation pushed the field just a little too hard, the ball would start rolling again. A true tachyon would appear, but it wouldn't fly past you. It would be the center of an expanding bubble of doom. Inside this bubble, the laws of physics would be rewritten. The new vacuum would have different properties. The constants of nature would change. Atoms would not hold together. Chemistry would fail. The speed of light might change. The bubble would expand at the speed of light, consuming everything in its path. You would not see it coming because it travels as fast as the light that would warn you. One moment, you would exist. The next, you and the atoms that make you would be deleted and reformatted into a strange, alien physics that cannot support life. In this view, the tachyon is the ultimate destructor. It is the trigger of the apocalypse. It is the mathematical signal that the vacuum is decaying. If we were to detect a tachyon field emerging today, it would mean that the stability of the cosmos has ended. It would mean the floor is falling out from under us. This interpretation explains why we don't see them flying around like butterflies. A universe filled with tachyons is a universe that is exploding, collapsing, or freezing. It is a universe in active transition. The fact that we are here, looking at stars that have burned for billions of years, suggests that the tachyons are gone. They have all rolled down the hill. They have all condensed. We live in the aftermath of the tachyonic era. We live in the quiet ruins of the instability. However, Theoretical physics is never quite that tidy. There are string theories, theories that try to unify gravity, and quantum mechanics that are plagued by tachyons. When string theorists work out the math of higher dimensions, tachyons keep popping up in the equations like weeds in a garden. For a long time, physicists thought these tachyons killed string theory. They thought, if your theory predicts tachyons, your theory predicts an unstable universe, and since the universe is stable, your theory is wrong. But recently, some have begun to wonder if these mathematical weeds are actually telling us something about the hidden structure of dimensions. Maybe the tachyons are confined to dimensions we cannot see. Maybe they are the vibrations of the strings that keep the hidden dimensions curled up tight. Or, perhaps, they are the key to dark energy. We know the universe is expanding, and that expansion is accelerating. Something is pushing the galaxies apart. Something is adding energy to the void. Could this be a very slow, very gentle tachyon field? Could we be slowly rolling down a very shallow hill right now? If so, the acceleration of the universe is just the ball picking up speed as it slides toward a new, unknown destiny. The instability perspective strips the romance away from the tachyon. It is no longer the magical particle that allows us to call our ancestors. It is no longer the engine of a warp drive. It is a structural flaw. It is the stress fracture in a bridge that screams right before the concrete gives way. It teaches us that existence is a precarious balancing act. We tend to think of the laws of physics as immutable, eternal commandments carved into the bedrock of reality. But field theory suggests that the laws of physics are just the current weather. They are the result of where the ball happens to be sitting on the hill right now. And the tachyon is the reminder that the ball can always move. So, perhaps it is a good thing we haven't found one. We search for them because we are curious. We build machines to hunt them because we want to break the speed limit. But if the field theorists are right, finding a tachyon would be the last discovery we ever make. It would be the discovery that the game is over. We have looked at the tachyon as a speedster, a time traveler, and a ghost. Now we see it as a harbinger of doom. But in all these guises, one thing remains consistent. The tachyon represents the boundary of what is possible. It is the edge of the map. And as we conclude our journey, we have to ask ourselves, why does the universe have an edge at all? Why is the speed limit there? Is it a wall to keep us in, or a shield to keep the chaos out? We have spent this entire journey banging our fists against the glass. We started with a simple, human frustration. We want to go faster. We looked at the speed of light, that absolute, unwavering number, and we saw it as an insult. We saw it as a cage that keeps us trapped in this tiny corner of the galaxy, separating us from the stars we long to touch. In our desperation to break free, we turned to mathematics for a loophole. We conjured the tachyon. We imagined a particle that lives in the mirror, a ghost that runs faster than light, a creature that treats our ceiling as its floor. We chased this phantom through the equations of relativity, down the slopes of quantum fields, and into the paradoxes of time travel. We wanted a speedster. We wanted a way out. But now, at the end of the road, we have to face the sobering truth. We looked for a way to break the law, but what we found was the reason the law exists in the first place. We have discovered that the speed limit of the universe is not an arbitrary number set by a cosmic traffic cop. It is not there to slow us down. It is there to keep us real. The journey of the tachyon has shown us what happens when you remove the barrier. We saw that if you allow things to move faster than light, you destroy the order of time. You allow effects to precede causes. You allow the future to assassinate the past. We saw that a universe with tachyons is a universe where now has no meaning, where history is a fluid hallucination, and where the vacuum itself might spontaneously collapse into a bubble of nothingness. This leads us to the ultimate conclusion. The speed of light is the guardian of order. When we look at the cosmos, we see a place of stunning, intricate structure. Galaxies spiral in graceful arms, stars form and die in predictable cycles. Planets orbit with clockwork precision. Even down to the atoms in your body, electrons follow rules. This structure is only possible because of causality. The rule that A must happen before B is the glue that holds reality together. It allows complexity to emerge. It allows for evolution, for memory, for consequence. If tachyons ran wild, this glue would dissolve. In a tachyonic universe, a star could explode before it ran out of fuel. A planet could shatter before the asteroid hit it. You could remember a conversation you haven't had yet. In such a chaos, intelligence could never evolve, because intelligence relies on learning from the past to predict the future. If the future is already leaking into the past, learning is impossible. Life, consciousness, and the very concept of self rely on the sanctity of the timeline. Therefore, the infinite wall we encountered in the beginning is not a prison wall, it is a sea wall. It holds back the ocean of chaos. It prevents the causal madness of the absolute elsewhere from flooding into our quiet, ordered reality. The reason we cannot run faster than light is because we are creatures of the story, and a story must have a sequence. The universe protects its narrative. This realization changes how we should feel about the vast distances of space. Yes, it is tragic that we may never reach the Andromeda Galaxy. It is painful to think that the light from the stars we see tonight left them 1,000 years ago. But that delay, that lag, is the safety buffer of existence. The fact that information takes time to travel is what keeps events distinct. It ensures that everything doesn't happen at once. The speed of light is the refresh rate of the universe. It is the maximum speed at which reality can update itself without crashing the system. We must also reconsider the silence. We often ask, where are the aliens? Or, where are the time travelers? We look for messages from the future, hoping for a lottery number or a warning about a disaster. But the silence of the anti-telephone is not a disappointment. It is a reassurance. The fact that no one has called us from tomorrow proves that tomorrow is safe. It proves that our choices today matter. If we could receive messages from the future, we would be actors following a script, enslaved by a destiny we cannot change. The silence tells us that the future is unwritten. It tells us that we have free will. The speed limit preserves our agency. Does this mean the tachyon is definitely a myth? Not necessarily. As we discussed, tachyons might exist as temporary fluctuations, or as the ghosts of fields that have long since calmed down, like the Higgs. But they are likely quarantined. The universe seems to have a built-in censorship mechanism. Perhaps tachyons exist, but they cannot interact with normal matter. Perhaps they are trapped in dimensions we cannot access. Or perhaps, as Stephen Hawking suggested, the laws of physics conspire to destroy any machine that tries to create them. The chronology protection conjecture is the scientific way of saying that the universe defends itself. It implies that there is a fundamental law deeper than relativity, which states, the story must make sense. We are allowed to stretch the rubber band of space-time. We can bend it with gravity, we can twist it with black holes, but we are not allowed to snap it. So, where does that leave us? We are back where we started, in the slow lane. We are made of bradians, slow, heavy matter. We are condemned to crawl through the cosmos at a fraction of the ultimate speed. We will likely never break the barrier. We will never outrun our own reflection. But there is a beauty in this limitation. Because we are slow, we are solid. Because we cannot be everywhere at once, we can be somewhere specific. Because we cannot talk to yesterday, we must cherish today. The constraints of physics are what give our lives weight and meaning. A game without rules is not a game, it is just noise. The speed of light is the most important rule of the game. We began this exploration looking for a cheat code. We wanted to hack the simulation. We wanted the infinite energy, the imaginary mass, the time travel. We wanted the magic of the Tachyon. But what we found was something more profound. We found the architecture of existence. We found that the universe is not a random collection of events, but a carefully tuned machine designed to preserve order, continuity, and logical consistency. The Tachyon remains the most fascinating maybe in science. It stands as a monument to human imagination. We looked at the equation E equals mc2, and we dared to ask, what if m is imaginary? We dared to look into the forbidden zones of math. Even if we never find a tachyon, the search has taught us everything we know about the texture of space and time. It forced us to define what it means to be real. As we close this chapter, do not look up at the night sky and feel trapped by the distance. Look up and feel protected by it. The light you see from those distant stars has traveled for millions of years to reach you, obeying the strict speed limit every inch of the way. And because it obeyed that limit, the image is clear. The history is preserved. The universe is intelligible. We are the children of the limit. We are the masters of the subluminal. And while our bodies can never touch the speed of light, our minds have already traveled there, crossed the wall, lived in the mirror, and returned home to tell the tale. That is the true power of the human intellect. We don't need to be tachyons to explore the impossible. We just need to be curious. Thank you for joining me on this journey into the fastest, strangest, and most dangerous idea in physics. It has been a ride through the looking glass, and I hope you never look at a beam of light the same way again. Good night, and I will see you in the next video.